get to the top of the next page, and we got to go to 229 and read the top of this page. So I'm up here. Many other variables affect pulse rates besides caffeine. Some of them, such as caffeine tolerance. If you drink a lot of caffeine and then you get into this exercise, it's not going to do much different to your heart rate. If you never have caffeine, it probably would. How much you weigh, recent caffeine consumption, like did you already have coffee today? Describe characteristics of the subjects. Those things all describe how the subjects themselves could be different. Other variables, such as how much sugar is in the soda, the amount that you have, what temperature it is, those are characteristics of the experimental process. To experiment well, we want to create groups that are identical or as close as possible to each other and treated in the exact same way, other than the treatment, which in this case would be caffeine. So here's the moral of that story. To experiment well, we want to create groups that are identical to each other, where both groups have heavier and lighter people. Both of them have people with caffeine tolerance and people without caffeine tolerance. People who drink a lot of soda, people who drink a small lot of soda, people who drank coffee earlier, people who didn't. And both groups are treated the same way other than the treatment. That's the goal, so that if there's a difference between the two groups, it's got to be because of the treatment. If the treatment groups are created so that they are different in some way, like all guys and all girls or something like that, or treated differently in some way. Some people just drank one of these sodas. Some people drank two of them, or maybe some of them had something that doesn't have a lot of caffeine and somebody has something that's overloaded with caffeine. If they're treated differently in some way, confounding is likely to occur. That's the thing that happens when more than one thing is affecting the response variable. We can't tell to what extent it's our explanatory variable versus something else. And that way our results would definitely be biased. Okay, the best way to pick the treatment groups is to get ourselves out of it and use random assignment. So that is principle number 2 of a well-designed experiment. Randomly put your people into groups. Okay, so let's wrap that up with a definition. The first principle of experimental design was control. The second one is random assignment. And here's your official definition. In an experiment, random assignment means that the experimental units are assigned to treatment groups using a chance process. All right, so let's go back to the example. We'll talk about a chance process. Okay, so I'm going to 229. We're already there. Who gets the caffeine? So my boy, Mr. Luckow's class, 20 students volunteer to participate in the caffeine experiment. How would you describe how you would randomly assign 10 students to each treatment? Okay, using identical slips of paper, here's what you do. On 10 slips of paper, write the letter A. On the remaining 10 slips, write the letter B. Shuffle them all up and hand them out to each person. Whoever gets an A slip's going to get the actual cola with the caffeine. Whoever gets the B slip, they will get a cola without caffeine. So caffeine's the only difference. They do actually go through some kind of a treatment, but it's the placebo situation because it doesn't actually have caffeine in it. Using a random number generator, label each student with a different integer from 1 to 20, and then randomly generate 10 different integers from 1 to 20. And you've seen how to do that. I'll do it right here. From 1 to 20, here we go. Nobody wants to see that. Nobody wants to see logarithms. I'm going to hit math, go to probability. I'm going to do a random integer. Oh, I'm doing with random integer, no repeat. I'm still not sure how this works. 1 up to 20, and I want 10 of them. There you go. I got 10 different people. So if I labeled everybody 1 to 20, those are the 10 that are getting the actual caffeine. All right, back to the notes, people. Oh man, I gotta read more stuff. Okay, on page 230, does watching TV make you snack? Interesting. Oh, look at all these words. Many people blame TV for the increasing problem of obesity in our society. Does the type of program influence how much people eat? According to a recent study, the answer is yes. 94 college students were randomly assigned to one of 3 treatments: watching 20 minutes of a Hollywood action movie, The Island, watching the same 20-minute excerpt of the movie with no sound, and watching 20 minutes of an interview program, Charlie Rose, I don't even know what that is. While watching, participants were given snacks: M&Ms, cookies, carrots, and grapes, and allowed to eat as much as they wanted. Subjects who watched the highly stimulating excerpt from the island ate 65% more calories than subjects who watched Charlie Rose. Participants who watched the silent version of the island also ate 46 more calories than those who watched Charlie Rose. Well, it's kind of an interesting experiment, but the question here is, explain the purpose of random assignment in the context of this experiment. I didn't even have to read all that stuff and get the results. I just want to know the random assignment. So let's go back to this. 94 college students were randomly assigned to one of 3 treatments. So they didn't get to choose what they watched. They were randomly assigned. What was the purpose of random assignment? I'm just going to tell you without looking at it. It's to make the groups as equal as possible. That's it. The purpose of random assignment is to create roughly equivalent groups at the beginning of the experiment. For example, if you let people choose which show they'll watch, it's possible that more males would choose the action movie. Okay, I guess. Because males typically eat more than females, we wouldn't know if any difference in calorie consumption was due to gender or the type of programming. So they're saying something that could happen that would put a bias in your data, not necessarily something that necessarily does happen, right? Save the author from sounding very stereotypical right there. Okay, the third principle of experimental design is replication. I said it earlier, but I didn't explain it at all. It's a real simple concept here. Here's the idea. If you only had 6 people for the watching TV thing, the 3 people randomly assigned to each group could create very different groups. If there's only 3 people in each group, they could be very different. There are not enough people for the random assignment to let outside variables, which is what a chance process is good at doing, even out. There's not enough people to let the outside variables even out. Replication of one treatment means don't use 10 people in your experiment, use 100. Okay? That way, lost my page here, went the wrong way. The 50 people in each one of your 2 groups, if you're doing 2 groups, are much more likely to be roughly equivalent than if you put 3 people in 2 groups, as opposed to 3 people in each group. All right, now, last thing. We should be able to notice other variables in an experiment and how they have or haven't been addressed. Okay, so I'm going to go to the example one more time. On page 231, more distractions, more calories. I'm here at the bottom. In the TV and snacks example from earlier in this lesson, researchers determined that people typically conclude more calories when watching TV shows with more distractions. Identify one variable that the researchers kept the same, a variable that they kept the same or controlled for all subjects during the experiment. Provide 2 reasons why it was important for researchers to keep this variable the same. Well, they all watched 20 minutes, and they all had food provided for them. They didn't have to get up and go get it anywhere, right? So let's see what they put here. Amount of time watching TV, that's the 20 minutes. If one of the treatment groups was allowed to watch TV for a longer period of time, we wouldn't know if the amount of time or the type of program was the cause of a difference in calories. If you're there for an hour, you're probably going to eat more, right? Also, if the researchers let the subject within each group watch TV for as little or as long as they wanted, the number of calories consumed would be much more variable than it would be otherwise, making it harder to tell if the type of program made the difference. So you keep things as like as you can to keep the treatment groups as similar as possible, so that you really are trying to just narrow in on your treatment to see if your treatment is the reason for the change. Okay, so that's the notes for today. Here's what I want you guys to do. Right now, go to page 232. I'll flip the page. I'll show you what I'm talking about. 232, there's an example that doesn't have the answers. So I want you guys to read this example and write yourself out some answers. I'll put my answers up in a second, and you can compare and see how you did. Do that now.